So now for example we are having the CNC lathe, we are having origin for the workpiece at 0 0, you are having the z axis and you are having the x axis. Now suppose there are 3 points which are present in the space, and these 3 points are the points through which the tool has to pass. So you are having P1, you are having P2 and you are having P3. So P1 and P3 are along the same distance from the spindle axis. P2 is closer. So here you are having the origin. So for P1 you are having positive x coordinate and you are having the positive z coordinate. For P2 and P3 the x coordinate will be positive because it is on the positive side. The z coordinates will be negative because they are behind the origin in this particular case. So these two will be having negative z coordinates, this will be having the positive z coordinate, and all the 3 points will be having the positive x coordinate. So you have to remember x coordinate means diameter at that particular point. So you are having the spindle axis or the center, so this distance will be the radius, so x coordinate will be the diameter at that particular point. Now for example, from the home position that is very far away somewhere, we have brought the tool to point P1 and we have rested the tool at that particular point. So now P1 will be the starting point. So the tool edge or cutting point or cutting tip is present at point P1. From there now we want to move, we can move to P2 or we can move to P3. We can move from P1 to P2 and then from P2 to P3 we can move depending on the requirement. Now say we want to move from P1 to P3, so we can move along a straight line. We can draw a straight line passing through the points P1 and P3, and we can move from P1 to P3 along the straight line. So the distance between the points P1 and P3 from the spindle axis is constant. So we are going to get a workpiece which is cylindrical in nature. Cylindrical in nature means the radius is same at both the ends, so you are going to get a cylindrical object. Now instead of going to P3, we are going from P1 to P2. So as we are moving from P1 to P2, what happens? So from the spindle axis, P1 is at a greater distance, P2 is at a lesser distance, and you are moving from P1 to P2, so the radius is gradually reducing or the diameter is gradually reducing. So we are going to get a tapered object. So you are having P1, that is a point here, you are having the P2. If you are moving from P1 to P2, you are generating a tapered object. Now not only we can move along the straight line, we can also move along a curved path. So because the movement from one point to another point, it need not always be along a straight line, it can also be along a curved path. So from P1 if you are starting, you can go like this, or you can go like this, or you can come downwards in this direction, or you can move downwards in this direction, or you can make even a different path. Now what is the difference between the 4 motions that are shown here? So if you are moving, if you are joining the 2 points by imaginary line, and if you are seeing, you are moving this one above the line, this one also you are moving the above line, so you are going to get something like a convex object, so as shown in the figure here. So you are going to get a convex shaped object. So this is the diameter at this particular point, this is the diameter at this particular point, and the diameter is gradually reducing, so you are going to get an object like this. So if you are moving along these 2 lines as shown here, then you are going to get something like a convex profile. So you can see here, this is the convex profile that is there, you are going to get a object like that. So depending on which path you are taking, this curve will be much deeper or it may be much shallow. So depending on how we are moving, the profile of the object will be different, but the start point and the end point are same. So P1 is same, P2 is same, but instead of going along a straight line, we are taking a curved path. So similarly for P1 to P3, we can go along a straight line or we can go along a curved path. Now when we are going on a curved path, we have to understand what is the difference for the various paths. So if you are taking the 2 curves here, upper 2 curves here, so this is the first curve and this is the second curve. So what is the difference between them? So the 2 curves are passing through the points P1 and P3, Then what is the difference between the curve 1 and the curve 2? The difference is the radius of that particular curve. So the lower one will be having a larger radius. So you are having 2 points and you are having the radius, and you can get a definite path. So if you are specifying the radius and you are specifying the coordinates of the 2 points, then you are going to get one single curve. But we have to also remember P1 and P3, the 2 points. You may be having one more curve here which is also having the same radius. This curve is also having the same radius as this one. Then how do we differentiate between this curve and the other curve over here, which is passing through the 2 points and having the same radius? So that is differentiated by using the direction from the starting point. So here the starting point is P1. Now the center for this curve will be somewhere along here. The center for the upper curve here will be somewhere over here. Now from P1 to P3, in what direction we are moving? So with respect to the center here, if you are rotating here, this will be in the counterclockwise direction. So from P1 to P3, it will be the counterclockwise direction. You are going to get the upper curve. So from P1 to P3, for this particular curve, the center will be somewhere over here. So from P1 to P3, if you are moving to get reach the point P3 along the curve, then it will be the clockwise direction. So this curve will be the clockwise direction movement. This curve will be the counterclockwise direction of motion. Same is the case for this one. If you want to move from P1 to P3 along this curve, then it will be the counterclockwise direction. If you want to move in the reverse direction from P3, if you want to reach P1 through this particular curve, that is the lower one, then you are moving in the counterclockwise direction. And if you are moving in the upper curve here, then you are moving in the clockwise direction. You are starting from P3 and you will end at P1. So depending on which is the starting point and which curve we are following, the direction will be clockwise or it will be counterclockwise. We have to be very careful. So the starting point, the end point, the radius and the direction of motion, these parameters are required to define the motion along a circular path. So to travel between 2 points, we can have a straight line motion or you can have a curved motion. So straight line motion is always fixed. There is no question of having multiple straight line paths. It is always the same from P1 to P3. But if you want to move along a curved path, then you have information about the direction, whether clockwise or counterclockwise. Then you should know what is the radius of the curve. With these parameters, we can fix the particular path along which the tool has to move.